This is the top level design of my digital lock. I use two subcircuits, one in which I implement my data stream and the other in which I implement my control FSM. My data stream receives inputs from the keypad as well as the RST signal. It also receives a clock signal. The clock input has been replaced with an actual clock in Logisim for demonstration purposes only. The data path also is what outputs the LED and lock information. That is the final output of the circuit. The control FSM receives information from the data path as well as a clock signal and outputs the current state. I will now describe how my data stream functions. As described in the previous slide, it receives input from the keypad as well as the RST signal and a clock signal. All of this information is fed into a subcircuit, that is my key detection circuit. This circuit outputs a one-hot code representation of what key was pressed and a signal that represents when a valid or invalid key has finished pressing. I store the previous two values of the key presses and compare it to the current value. If the combination of these keys matches the combination of the set unlock code, then I have an output that represents that the lock should unlock. I also have a comparison section in which I compare the previous two values and determine if this is a valid lock sequence. The data stream is also what determines the output of the overall function. So I use the current state in order to determine what the values of the outputs should be. I will now describe my key detection circuit. I receive all the inputs from the keypad and the RST signal. I determine if it is a valid input, that is, that only one key is pressed. Once the key is unpressed, I will output a signal to tell the other circuits that a key press has just finished, and I will also feed it a one-hot code representation of which key was pressed. If an invalid key is pressed, I represent that as just another bit of information on the output one-hot code. I will now describe the control subcircuit of my project. It is this section where I implement my control FSM. This subcircuit has 5 inputs: a clock signal, a one-hot code representation of which key is pressed, a signal that tells the circuit that it should unlock now if the next key pressed is the unlock key, a signal that tells the circuit that it should lock if the next key press is the lock key, and a signal that tells the circuit that a key press has just finished. The output of the circuit is 5 outputs. Each one represents one of the possible states of the finite state machine. The gates in the middle here are what I use to transition between each state. I will now display the overall functionality of my top-level lock controller circuit using the test bench that was provided to us. I will now start a simulation. If I click start, the blue LED should turn on. If I click the L button, the lock should turn from unlock to lock. As you can see, that has occurred. I will now unlock it using the user code. So I click start 3, 1, 4, unlock. As you can see, it has unlocked. I will now attempt to lock it using incorrect code. So I click start 8, lock. The red light has come on like it should. I will now lock it using the correct code. Start, lock. I will now attempt to unlock it using an incorrect code. Start 3, unlock. The red LED has come on just as it should.